ahead. The recording has started, and we've got a pretty good group of 20 of us here. So welcome, everybody.
All right, yeah, welcome everybody to our experimental weather watch. It will soon become standard. We're going to do this every Friday electronically, the way we've done it before, of course, down in room 811. And we're taking advantage of the necessary spin up as well as emptiness in the Monday colloquium schedule to talk a little bit about the weather today at 3:30. So that's why we're doing this right now. And so if you've never been to the Weather Watch, you'll see kind of the broad picture of how we do it. If you have been before, you'll notice that it's quite similar today to what it often is. So we start usually with a satellite image or a satellite movie, and we're looking at now the contiguous 48 states and adjacent waters here in the.
Hey, can I break in just for a second? Michael, would you mind muting your mic just now? There's a little bit of background noise going on, and I think if you mute and we just have John on there, that'll be better.
All set?
Yep, all good.
Okay. So here we're looking at the continental 48 and adjacent waters, and in the colored infrared image. And it's quite an active day across the southeast United States, particularly the Carolinas, Mississippi, Alabama. We'll talk a little bit more about that when we look at the radar. And you can see that the cloud mass associated with that intrusion of there's an upper wave across the Great Lakes that we'll see when we go to 500 millibars that's kind of contributing to the development over New England. And then one can see, even in this movie, a continuous stream from the subtropical eastern Pacific going across the northern states of Mexico, Gadsden Purchase area of Arizona, into the southern states. And that's been a day of substantially heavy weather across, as I said, parts of Alabama, northern Georgia, and now into the Carolinas. And this is just about exactly the peak of the tornado season. It's not tornadic today, but it's the peak of the tornado season down in the United States from about mid-February to the end of March, maybe mid-April. Then it moves, of course, into the higher plains, or the central plains, and then further northward. So it's kind of interesting that we're seeing something like that across that part of the world today. Across the central part of the United States, this is a really nice image to look at this time of day. You can see well to our west in northern Minnesota and into the Dakotas and Nebraska, the skies are clear, but there's low stratus or low clouds over us, and have been all day, of course, on a gloomy first day of our miserable hiatus from our beautiful campus. And you can see a few pockets of openness looking. We had a little bit of sun around 11 o'clock, but it poked through, and then it kind of got redone by clouds. And that's generally the case across the central United States. So the weather is relatively settled, but not particularly attractive. And then you can barely get an oblique view of the West Coast. We'll look at that a little bit more later on. But you might notice, even from this image where my cursor is, just cold air spilling out from the continent over the water, some open cellular convection, but really hint of higher clouds and maybe some more organized disturbed weather past the date line or near it. So we'll see that in just a minute. Okay, so let us now go to the radar across the continental United States. And we'll get a view of some of this exciting weather across New England as we do it. So some of this is cold enough to snow. We'll see when we go to the surface maps. There's some snow in southern New Hampshire and parts of Maine today, but you can tell almost just by inspection of the radar that it's not snowing over Cape Cod. That reflectivity is way too high for that to be cold and snowy, is my guess. I haven't looked at the surface map, I'll confess. And then I think it's raining also back over the Hudson River Valley and to the west of that, and then south of Long Island. And then here, what had been a fairly interesting convective morning across these parts of the south, the Mississippi, Alabama, Georgia area, has kind of decayed a little bit. There might be a little bit of thunder rumbling through Atlanta or the northeastern suburbs, but that's about it now. That's about done. Nothing across the Great Lakes states, as you can see, and really spotty open cellular convection coming into the Puget Sound area. So this is really small updrafts, not very big downdraft areas surrounding them. So that's probably not much colder than about minus 25, minus 27 at 500 millibars. We'll see when we go over to the upper level charts. Earlier in the day, and you can see just a hint of it here to the east of Portland, there was a little bit better organized precipitation. That was the cold frontal band that came in with a storm that's up kind of located off the northern tip of Vancouver Island. And what's characteristic of the Puget Sound area, any place on the coast actually, the west coast, is when the front goes through and the air gets colder, not only at the surface but at upper levels, one sees the stability decrease with a nearly constant surface temperature. the stability goes down and you get convective showers. So it was quite curious when I first moved to Seattle that after the front goes through, there's more precipitation in post-frontal convection than there is along the front. And that's characteristic of the West Coast, especially the Northwest Coast. It's happening today. So that's interesting. And then we can go to the West Coast infrared movie, which is loading right now, as you can see. And really interesting picture here today. Now, to me, to my eye, one thing is you can see the cyclone that's just there on the northern tip of Vancouver Island. That's where most of the convection is clustering, but one can see evidence of quite a wide, extensive region of not very deep and not very intense open cellular convection back in the colder air. So we'll see when we go to 500 millibars just how cold is this air, and I'm guessing it's around minus 25. And my guess is based on the spacing of the cells. When they're widely spaced, that suggests a really vigorous updraft and therefore much wider regions of downdraft, and that accounts for the spacing. So if it's colder aloft, you get more vigorous updrafts, and so you know you're going to be minus 35 with a less speckled look to these convective clouds. Well, let's see if I'm right. And then the thing that I notice about this picture is once you get to about 160 degrees or so east, there's west longitude, there's Hawaii, down where the cursor is. That's when suddenly you get a lot of active weather. And there's nothing between that longitude and the West Coast. It's widespread anticyclonic or at least well-settled conditions. And then here it's just a mishmash. It doesn't even look like our planet in terms of all these weird little circular disturbances of small scale, and it's a mixed up mess. And we'll see one of the characteristics of the current situation, large scale Pacific Basin circulation is an extraordinarily retracted North Pacific jet, maybe as retracted as I've ever seen it. And it follows exactly the evolution to get to that state that Melissa Breeden wrote about in her PhD thesis. So she really nailed the whole evolution of this, and I'll show you a little bit of that from Pivotal Weather. So that's kind of an interesting situation that's going on a slightly larger than synoptic scale. So let's now take a look at some of our current observations. We'll go to upper levels first. I'm talking fast here, Pete, so if you want to jump in, you won't be upsetting me if you've got questions or anything you want to talk about. But I'll show the 500 millibar map over the continental United States and adjacent waters, and you can see, well, let's go out to the Pacific Northwest first. Oh, it's colder than I thought. Minus 29 at Quileute, minus 35 way up in the northern tip of Vancouver Island near Nanaimo. So it's about 6 degrees colder than I thought it was. So that's a pretty good cold pool. The minus 25 isotherm out here really does look roughly like the front edge of that speckled open cellular convection. So something about that guess was on the right track, but not the core of it. It's much colder at the core than I thought. So that's interesting. I didn't mention it, and we didn't see it so well in this afternoon's radar, but there was unsettled weather over Southern California today that was easier to detect at 11 o'clock when I gave class, and you could see some widespread showers in that part of the state. They've kind of moved to the higher terrain, and perhaps now they're somewhat compromised in their signal by the higher terrain itself. But there's an upper wave that's just made it across the west coast, the southern coast of California, and you can see a pretty decent region of ascent ought to be out in this region downstream of the cyclonic curvature region, and that'll be sort of in the southern Nevada location. And so over us, broad but not really exciting ridging is to our west, and that accounts for, I think, the fairly featureless weather map that we've seen across the central United States. And then a broad trough with only slight anticyclonic curvature downstream of it. That's enough to have produced and sustained this precipitation that's over New England, and we've seen that in the radar up to this point. So not particularly baroclinic flow anywhere except on the fringes. I'd say that's true here to the east of Greenland. It's really strongly baroclinic in that upper trough, and fairly strongly baroclinic in this northwesterly flow off of southeastern Alaska. But other than that, the flow is considerably weaker in terms of its baroclinicity than we've seen earlier in the last, well, not earlier this week, but last week, with the exception perhaps of Southern California, where it's fairly impressive. Look at the ridginess at 500 millibars. That's out at the longitude of the western Aleutian Island chain. That's quite dramatic, and we'll say, as I said, a little bit more about that in just a minute. We'll go to 300 millibars next and take a look at what we see over this same. So One gets the impression there's a really strong subtropical jet here, although we'll see it probably stronger even at higher elevations, which we'll visit in just a minute. And that's cutting across the southwestern United States into the central U.S. and then heading straight to New England. So here's the trophiness that we mentioned just to our east, and downstream of that is where the unsettled weather is over New York State and New England. And then some of the convective activity earlier today was on the anticyclonic shear side of this upper level wave. And of course, that upper level jet, and that jet separates tropical air to the south from considerably cooler, more polar air to the north. And that is characteristic of some of the conditions that led to that activity, the convective activity down there. And then a broad wave off the west coast with a polar jet emerging in northerly flow on its western side. That tends to dig these troughs, of course, because in the exit region of the jet is where there's upper divergence. And so you're going to cool the air by expansion in such a region, and that's going to lower the heights hydrostatically. So that anytime there's a jet on the western side of such an upper trough, it's going to be hesitant to move out. It won't be so progressive, and it may even deepen. So that could mean extended periods of unsettled weather in the Pacific Northwest, perhaps mostly Canada, but certainly possible Pacific Northwest of the United States. One last thing at upper levels, I want to just see how much more intense, if at all, the jet gets down over the southwestern United States if we go to 200 millibars. And that indicates a little bit more about what the nature of it actually is. And we had the maximum ice attack value was about 120 knots in the purple at 300 millibars, and here we're well over 140, 150, approaching 160 in a couple of locations over the panhandles of Texas and Oklahoma, for instance, and then down to Southern California. So this is a very strong subtropical jet. That's consistent with what we saw on the satellite movie, with a stream of at least some high clouds and presumably water vapor throughout the column coming from the eastern subtropics of the Pacific. Notice also the disappearance of the polar jet features aloft in terms of their intensity, because we're just above the jet core now at 200 millibars for polar jet type features, but we're not above it for the subtropical jet. That's quite characteristic. Now I think I want to look at some surface observation maps across the country just for a minute. This is the big one, I hope. Yeah. So let's look at the big one, and we'll start over in New England. And son of a gun, it is snowing in Boston. How do you like that? 34 over 31. It's raining over Cape Cod. It's raining everywhere else to the south, raining in New York City. What a sad city New York is right now. 41 over 41, and lots of trouble for the New Yorkers right now. We got to hope that things get better for them. It's snowing in New England, snowing in southern Quebec, and snowing at Albany, moderate snow to the west, and some snow in the lee of the Great Lakes. So much of New York State with some snow today, and then a good part of New England snowing as well. It's raining in Providence. It's raining at Martha's Vineyard, or Nantucket. Then we go to the south. This is really interesting. I'm going pretty far south because there's some interesting observations down here. And namely, let's see, I'll slide it over. Take a look at some of these dew points down here in Mississippi. We're 72 degrees right on the Mississippi Gulf Coast, 79 over 72. This is the first 70-degree dew point I think I've seen all year. And we're only 2 or 3 days into the spring. So this is a really moist, tropical sort of air mass, widespread 70-degree dew points along the coast. And these are probably record high dew points, and maybe there's even some record high temperatures. I don't know that that's the case, but I wouldn't be surprised that we might see some in the next day or two. So widespread 60 dew points. Then when you get to northern Mississippi, northern Alabama, you're a little bit drier than that, 51 here in far southwestern Tennessee, and then only 36 in St. Louis. So the gradient of water vapor and temperature is extraordinary. Look at the difference between like Jackson and St. Louis. 30-degree temperature difference, 30-degree dew point difference. Unbelievable. And all the heavy activity down here we saw earlier, this is to the east of Atlanta now, rained pretty heavily in isolated showers. Let's see.
John.
Yeah.
I was going to say that also with that temperature and dew point contrast, there's also a subtle wind shift, or maybe not so subtle wind shift. Like if you look at Alabama, that station 61 over 59, and Birmingham is 69 over 65, wind shift there. So there's a weak front perhaps that exists right through there. And you can also see the pressure trough. That's where your cursor is. It's one of the lower pressures between those two stations.
That's true. That's true, yeah. Yeah, it's also right in here too. You're right. So it's higher to the east and higher to the west than it is right along here. Some of that might be mountains in these stations, but not down here in Alabama. Yeah.
Right.
That's a good point. Yeah, so it's maybe a weak feature at the ground, but when it's a weak feature, weak convergence feature, weak dynamic feature with extraordinary dew point gradients across it, that doesn't matter that it's too weak. You know, they've got something going on. And remember, the axis of the jet is right about across the center of this page, right along the line where I'm going back and forth with the cursor and giving you all vertigo. You know, so there's a tendency for inertial weakness to the south of that. Any updraft is going to have an easy time exporting mass anywhere it wants. And so you can get some showers that are pretty intense. This is a moderate rain, and it's we saw on the radar. It doesn't look that impressive, but a couple of those showers must be pretty good. And this is all polar air to the north here. We're still 43 over 32 here. It's kind of a miserable, cloudy day. But notice to the west, all you need to do in late March is have the sun come out. This is not really a different air mass, but the temperatures are profoundly different. We're 10 degrees warmer broadly in South Dakota and in parts of North Dakota just because the sun's out. That's nice. We're also going to have some lee-side subsidence off the Black Hills. Look at 60 degrees at Rapid City. Is that crazy or what? Unbelievable. Okay, going to the west, some rain across the Pacific Northwest. Only a couple of stations actually reporting it. Quillute's one of them. And then some of the coastal stations on Vancouver Island. This is well north of the city itself. The city's on the mainland. Victoria's on the island. That's weird. And then it's raining down in central coastal Oregon too. So probably, you know, intermittent showers, as we saw. It was kind of convective in that location. And then we're pretty warm in Southern California. The unsettled weather has moved into Arizona. There's a little bit of light rain associated with I presume, the ascent that's downstream of that upper trough in central Arizona. And then there's a little bit here that in Colorado that may be also affected by this broad region of presumably of ascent that's going on in this location downstream of that upper trough. So that's the way that things look at the surface, and it's cold in Alaska. Oh, look at that heavy snow, 4-star snow. That's pretty good. Is that Fairbanks? I think it is. So that's nice. Big snowstorm in Fairbanks today. And then very cold polar air along the north coast of the archipelago, or the continent, and then the archipelago, all temperatures below zero. So there's still some cold air in the hemisphere. It's just luckily relegated to high latitudes. I wanted to show you just one other thing, and that is the 200 millibar winds in geopotential heights at, I don't know what that's all about, at 12Z this morning. And so here's the Pacific coast, which I'm going down along with my cursor. And then here is Kamchatka and northern Japan. And so here we are on the western part of the Pacific Basin. And Hawaii is right here, so longitude 160 degrees. And this is approximately 180 degrees. The date line's approximately the climatological position for the exit region of the Pacific Jet. So the exit region of the Pacific Jet is displaced considerably farther west than normal. That we call a retracted jet. And retracted jets are characteristically associated with anticyclones downstream, which is part of the reason why the jet is retracted. And this one is pushed as far to the west as I've seen in a long time as a retracted jet. And I was talking to Melissa about it a little bit earlier today, and she and Andrew Winters have been watching this whole winter and noticing that there's been more jet retractions in the Pacific this year than they've been able to, what they expected anecdotally anyway, not really submitted yet to an analysis. But it's been an unusual year in the Pacific. And I think I've mentioned on many Fridays throughout the fall and winter that we haven't had a lot of really nicely wrapped up cyclones in the Northeast Pacific, which we like to often see rolling in to coastal West Canada. And that's consistent with a retracted jet. So quite an interesting winter has gone on here. You know what? I went to the wrong place. I wanted to go to tropical because I could have gone back 3 days and shown you that the evolution that's led to this retracted jet is precisely the one that Melissa identified in her PhD thesis, and that is anticyclonic disturbances get unfolded as they come out of the Pacific Jet. Some of them emerge from the tropics, some of them emerge from high latitudes over Siberia, and they set up quite a wavy flow, and many of those anticyclones merge and then break at high latitude. And this happened in this case. There was an anticyclonic wave break over the west coast of Canada that really helped to establish ridginess in the central part of the Pacific, which was obvious in the satellite picture. And that's part and parcel of the large-scale dynamics that at least encourages jet retraction. So very interesting case that looks a lot like the ones that she's done a thorough QG PV inversion diagnosis of in the recent past. So we're kind of encouraged that we've learned something about how these things work. We're still eager to understand better what the connections are in phasing between high latitude disturbances and tropical disturbances, and whether or not they must phase in a certain way to have a fairly intense jet retraction, or whether or not they are, they can occur almost in isolation and still encourage the same sort of evolution. We don't know the answer to that yet. My guess is, at this point, I think they need to work together, but we'll have to wait and see. So that's all I have for the discussion.
Can I show something on these jets with the global analysis on the jets? Do you have a second to show that?
Yeah, I got no agenda, so go ahead, Greg, if you can load it in. I think you're a presenter, right?
I'll let me make him a presenter. John, you'll also have to stop sharing your screen for him to be able to do that.
Okay, so I got to go back here and stop sharing the screen. Okay, so I'm off.
Yep. There you go. Greg, go for it.
And what do you see with me right now?
Nothing yet.
Share content, right?
Yep.
Yeah, share application screen.
Right.
Share entire.
That's a whiteboard.
No, I don't. Share application screen. And hello.
Would be the Safari or Chrome or whatever you're trying to show us.
Yeah, okay. I got a Viz 5D screen here.
It's a pretty good crew. We've got like almost 30 people on, including ourselves,
wow.
but it's a good group. Brent keeps jumping up. I'm not sure what's going on with him. Yep, you're up, Greg.
Okay. All right. This is the global analysis of the jet stream, and of all the jet streams. These are 40 meters per second or greater, and you can see the subtropical jets going across the Pacific and a kind of withering here. But here's our strong subtropical jet in the southern North America, and then we have a subtropical jet going across northern Africa. This up here is the polar night jet. These little jets up here are.
Hey, Greg, the thing, cursor is not showing up on there, so you'll have to tell us where you're actually pointing. We can't see your mouse on there.
I'm pointing across the northern hemisphere through Asia and then southwest United States and then into the Atlantic over Africa. And these jet streams here that you say have the shading that look like a watermelon on its southern side, those are subtropical jets. The watermelon shading shows the low potential vorticity on the southern side. These jets are running, peaking around 12 kilometers above the ground. Up here, above that, if you look from Eastern Asia, north over the Aleutians, you see the polar jet going up into the polar night jet. And this kind of turquoise, green, whatever jet going around the top is the polar night. So if I tilt the, you could see my cursor here when I do this? No. Okay. If I tilt this up, you can see that polar night jet goes up real high. See how high it is? It goes to the top of the grid. That's at 23 kilometers. So the polar night jet is very, very high. But what's interesting are these 2 points of intersection. Go back to the original overhead view. The 2 points of intersection, one over the Aleutians or just north of the Aleutians, and one in the Atlantic. These intersections, they are associated with a continuum of that jet from the low levels all the way up into the polar night. So there's, as we keep showing, there's some relationship of what's going on there to our east. It's not as strong of an intersection as we've seen, but it does go all the way up. At the same time, you can see the southern hemisphere has a lot of little jetlets down there. Some subtropical, some polar, but the southern hemisphere is just now starting to form a polar night jet. There's nothing up high in the southern hemisphere, as you can see. If I, just to look very quickly, if I change the contouring interval to 25 meters per second, or about 24 meters per second, see the southern hemisphere is starting to get a polar night jet now, but very on and off, very low intensity on and off. But northern hemisphere, we got this polar night jet, and if I go up to the very high numbers, like 80 meters per second here, you can see the polar night jet still has maximum that high. So it's a very, very strong jet stream, and in these two places is where the polar jet is ridging up high, and the ridging in the Atlantic seems to be associated with the ridging in the polar night jet for whatever that reason is. It's just interesting to look at, and I think there's major connections here between what we're seeing going on in the northern hemisphere right now and the remaining connections with the polar night jet that are still there. So I just thought I'd point that out. Okay. I'm done.
Thanks, Greg.
And
If you could unless you're going to show something else, if you want to share your.
I want to share. I got to end this sharing, right? Like that.
Right.
Okay.
Yeah. Okay. And I'm not able to do any sharing. Hold on a second.
We're learning.
Pete, if you wanted to show the Climo stuff, I need to reconnect. There's something wrong with my.
Okay, John, if you want to unmute
And the
your
link.
screen, go ahead too. The only reason I had muted you, you were typing back and forth.
Yeah, I didn't even think of that. That's a good point. I'll have to keep track of that.
That's not a problem. I'm getting in the habit of muting and unmuting as well. Let me see if I can find. I gotta find the tab that I've got stuff open in. One of these. I think it's this one.
I'll be back on in a sec.
Okay, sounds good, Michael. So I should be sharing a Chrome tab that has just that's not the climate stuff yet. Here is the Madison climate summary for the year so far that Ed put together for us. So you can see the last couple of days where we've all been stuck inside, and it's been not real super nice to be outside. We've been definitely below normal. We should be up around 50 for a high by now. Lows just below freezing. I did bring my plant in my coffee cup pot from my window home, and so far it seems to be tolerating the relatively cool temperatures. I've been bringing it in the garage at night and putting it out on the front porch during the day so it can get some sun, and it hasn't died yet, so there's that. And let's see, here's the precipitation today. So we've been above normal pretty much since October in terms of total precipitation, liquid equivalent. And then I don't know how that's coming through on there. I can see it pretty clear on my screen. Hopefully
yeah, I can see it pretty good.
This is the snow so far. So we had that huge dump right at the end of October, and then a big drought, and then we've had little bits and pieces ever since then. We're sitting right about normal, just a little bit above normal. Looks like we've got, what, 54 inches of snow, whereas a normal for a year would be on the order of 50, so not terribly crazy, pretty average for snow. So let's see, what else can I show? This came through, sent this out on Twitter today, and I can post this URL in the chat if you guys want to check it out. It is a year of geostationary satellite imagery from the Himawari satellite. So if you go on, I don't think the audio will come through. It's got some pretty strange audio to it. But if you go on, click on the link for the film, and you can get, here's just an example of what it looks like.
Whose satellite is this?
This is from the Himawari Japanese satellite.
Japanese, okay.
And they've got basically imagery. So
this is a filmmaker with an eye.
Yeah, no, it's so cool. So
Nice.
I mean, I'll share the link in the chat if you guys want to check it out. It's going to look way better on your screen than in here.
Yeah,
but
that looks great.
It's about a 15 or 16 minute long movie of a year's worth of imagery, so that was pretty cool. And then these are just some maps. I'm in the middle of still working on this. This is what we were showing right before things all got crazy. My Python-based replacements for some of our maps. So if you like the color scale or the whatever of our maps, looks like I just started this afternoon. I didn't run it, and they're not running regularly yet. But you can get like sea level pressure and precipitation every 3 hours. Some of the various other maps that typically were available on our site. So
Yeah, they look great, Pete.
I'm going to be spending some more time on those when I'm working from home. So hopefully I'll be getting some isentropic maps and some northern hemisphere maps and some other things that are worth looking at. So.
Okay, Pete, I'm back, but I'm not. I don't know if I can share anything yet.
Let me check in. I may not have you set up as a presenter.
No, that is uncool.
Well, no, I thought I had him set up as a presenter.
I'm kidding.
Let's see. I'll stop sharing for now.
Yeah, you don't have him on there as a presenter.
Hang on. Michael
I'm on as MCM.
is. Yep, you are now a presenter. Give it a try.
Okay.
I mean, if not, it might be something with the web browser that you're using that won't let you share.
No, it should allow me now, but I don't see where the sharing window's not coming up. If you could go to sol.aos.wis.edu if you don't mind driving.
Sure. Let me go share my screen again. There's the same one.
And we'll start with the familiar. John's favorite meteorogram.
I love the meteograms. As
Right.
you know.
So one of the things to note when we look at the meteorogram, certainly mild temperatures, some of the mildest we've seen this semester, and just a slight chance of some precipitation at the very end of this 60-hour forecast that was initialized at 12Z this morning. So increasing dew points, maybe some of the moistest air or the highest water vapor content air that we've seen in a while, in addition to warmer temperatures. Let's go to the time height section, please. And on that, we're going to see, not a particularly interesting pattern over us over the next 60 hours again. If you look in the lower troposphere around 18Z or 6Z tonight, you'll see in the boundary layer a sort of varying wind pattern with height, increasing height, indicative of warm advection. And that's consistent with our temperatures beginning to warm up. And that basically persists throughout the period until we get it to the very end of the 60-hour forecast. You'll also see in red the relative humidities approaching 90% in the boundary layer. So pretty moist boundary layer, probably likely going to be suggestive of a lot of clouds over us the next couple of days, but increasingly milder temperatures. Curiously, even though it's getting warmer near the surface, at upper levels tomorrow afternoon or tomorrow morning, tomorrow afternoon, you'll see that the tropopause dips down a little bit, and there's some modest cooling in the mid and upper troposphere, 400 to 500 millibars. You can see the isotropes there bowing upward underneath that dark or that bright green PV strip that's sort of consistent with a PV anomaly in the upper troposphere going by. And so stratification is going to get just a tad weaker, but it doesn't look like we have much in the way of precipitation to be concerned about. And there's no significant vertical motions as well with this upper trough that passes by. And then once we get to the very end of the period, the advections become almost neutral, but we see that the vertical motions increase significantly. And we'll see that's going to be associated with a front that'll be just toward north. That'll give us a chance of rain showers or even thunder showers or maybe thunderstorm, John, if that's your preferred term.
I think that's the actual term.
Yeah, that's actually right. Good point. Fair point. Actual term is thunderstorm, although they should be a thunder shower. Anyway, that's a longer discussion for a different time. Let's go back, Pete, to the main map. First, want to get a sense of the sort of PD over the southern United States. We'll go, or across the United States, we'll look at the loop beginning the 305 to 315 GIF or GIF loop. We'll start that loop off, and we'll see as we advance through this. And maybe I should have done it with a as a stepping through this, but we'll let that animate once more, and then we'll stop it, Pete, and we'll go to the 6-hour forecast just to start off with the current time. And this is really kind of neat. Our forecast city is Astoria, Oregon. We'll point out where that is in just a moment. But you can see this broad upper trough, or if you will, ridge of PV, but there's an upper trough, high PV air that's moving in the Pacific Northwest. And as John was indicating, following the frontal passage along the west coast, that's when kind of the showery weather occurs. showers. I mean, I guess typically we think of showers occurring ahead of a front and then maybe steady precip behind it is a little bit perhaps a different setup. With very unstable air aloft moving onshore, that's going to cause some showery precipitation. But I imagine also with a persistent westerly flow, we'll see that sets up, any mountainous regions along the west coast with windward facing mountains are probably going to pick up some precipitation over the next day or so. So there's the upper trough. We can see it there. You can see an upper trough departing our area if you'll go over to the central part of the United States, over Michigan at 18Z today. That's heading out to the east, and we see this broad ridge that's attempting to set up over us. Let's go ahead to 24 hours in the forecast, please, Pete, just in the interest of time. Okay, so 24 hours in the forecast. This is tomorrow morning. We see this little small blue area in the PV along northern Iowa and southern Wisconsin. That's being advected over us tomorrow. But it's a pretty small scale feature, and since this feature is pretty small scale, it's not going to cools the upper troposphere. It doesn't do much in the lower troposphere, and so we're probably okay as this goes by. But you can see along the Pacific Northwest, going back to the northwestern part of Oregon where Astoria is located, we can see at upper levels this upper trough is still seated over them. So showery wet weather is perhaps going to be indicated there.
Yeah.
But let's go ahead to 18.
Can you guys see my
36
mouse
hours forward?
Do you see my mouse on the hovering in
Yeah,
there?
I can see it.
Oh,
Yeah.
okay. I didn't
So
know
36
if that was
hours.
a thing or if that was.
Yeah. So 36 hours. That upper trough continues, the little PV anomaly continues to move by, and we're still under ridge conditions with a westerly flow. And as John has indicated many times in our map discussions, we'll see this in a moment when we look at the 850 millibar temperature. This westerly flow in the middle and lower troposphere is going to be associated with some downsloping and warming as it's spreading across the continent. So we're going to see with this westerly flow that gets established, we're going to see temperatures continuing to increase over us over the next couple of days, and that's consistent with our forecast. So let's actually take a look at that. Let's actually go one more time period out, and then we'll look at that. 48 hours at 3:05 to 3:15. Okay, so we see the tropopause beginning to lower toward our west, but again, this broad westerly flow sort of pretends a relatively warm weather regime over us, but we can actually check the temperatures out. Let's look at 850 millibars. We'll start off at 6 hours into the forecast. And you can see over us, with that departing upper trough we saw at 500 millibars, you can see the cold advection is just about over us with westerly winds at 500 millibars. The temperature advection is pretty much neutral at this point, with the minimum temperatures just through the center part of our state. And then the warm advection really begins to pick up over the northern plains, over western North and South Dakota and Nebraska, where you can see the cursor. Pete has that cursor. You can see a broad area of warm advection that's occurring there. Also, looking out to the western part of the United States, we see that front has already made it onshore, and cold advection occurring in northwestern Oregon, and that's going to be, again, associated with cooler temperatures for them, as well as some precipitation with that onshore flow and for showery precipitation. Let's go back a click and go ahead to tomorrow morning. And you can see tomorrow morning we're still in warm advection. I mean, that cold air is kind of stubbornly leaving us, but you can see over across the northern plains, across North and South Dakota, a nice trough is formed, and sort of hydrostatically in response to that flow across the mountains, and really warm across southern Texas at 850 millibars. And so the warm advection's on. We should be warming up. We didn't see much in the way of ascent over us, so this is truly going to be warm advection that's going to be able to warm us up. Yeah, John.
Yeah, it's really interesting, Michael. This is a good discussion. I think I'm wondering about the potential for continued stratus over us. If we get warm advection in the lower and upper and middle troposphere, and yet it can't really dislodge the cold air, as you're pointing out, how are the clouds going to dissipate? It's going to keep getting more and more stable. It's going to be ugly.
Right. Yeah. I mean, we saw the warm advection was already just to our west in the earlier maps, and it surprisingly hasn't advanced over us at this level, and so we're probably creating very strong stable air that's going to be difficult to mix out unless we can bring some dry air in here. So that may be a feature that could actually put a damper on how warm we can get at the surface, but certainly aloft it looks like it's going to be warming up nicely. So that's a really excellent point. That's probably, we saw when we looked at the time height section, where this very, increasingly humid in terms of relative humidity boundary layer. Maybe this is, it's all part of that same picture.
Yeah, it could
sort of
be.
trapping the moisture, the water vapor in the lower troposphere. Let's go ahead, this is at 24 hours. Let's go to 36 hours tomorrow evening. We were in the blues at 8:50. Let's see if we've gotten beyond that. Well, we've warmed up a little bit. It's stubborn with the south and southwesterly wind. So that even though we have this warm advection occurring, we're not warming up as much. But it's curious, the vertical motions weren't particularly significant. You can imagine having a warm advection and the temperature's not increasing because of significant upward motion accompanying that, so that you basically keep temperatures steady. But we didn't see any evidence of that in the time height section. So this is kind of a curious setup. Certainly beginning to warm up well to our northwest.
Yeah, and you can have uniform warm advection and no forcing for ascent, but that doesn't by eye look like it's uniform. It might actually end up being that way. If we did a calculation, you might see it's just about the same everywhere. Yeah,
that's an excellent point. And then we go ahead to 48 hours in the forecast. Can we get out of this dark green and at least warm up a little bit? 8:50, and it stubbornly tries to warm up. Looks like we're going to get into the warm sector of that cyclone that's in north central Ontario. But you can see the warm sector extends all the way south-southwest from that into the northern plains. And you can see that beautiful sort of thermal ridge that's just to the east of the Rockies and the pressure trough that's formed in the lee. So it's potential for a lot of warm air just to our southwest. And the question is, will that get in before the cold front associated with that disturbance in Ontario? We'll go ahead to 54 hours. $8.50. Maybe we break into some warmth on during the day. That's Wednesday afternoon. We may actually break into a little bit of warmth, get into the warm sector before those showers come in. You can see a really nice cold front, at least 850 millibars, setting up across the southern third of Minnesota. You can see a nice diffluence in the flow, frontogenesis that's occurring there, and that's going to perhaps bring an end to our relatively mild weather. Pete, I know I didn't. If you don't mind briefly switching to bring up a terminal.
Sure, one second here.
And we'll look at some of the numbers, the MOS numbers for Madison for the next 2 days, and we'll also look at Astoria. Hey, Greg. For some reason I was unable to share my...
I've got to get logged in here. Hang on once.
Okay. So what we'll see when we look at those MOS numbers, MOS is forecasting with no precipitation between now and through tomorrow. 52 for tomorrow for a high, 58 on Wednesday.
Whoa.
With basically our temperature staying at or above freezing through the entire period. We've actually dropped below. So if we do a /new AVN MOS, and we do MSN last, you can see that 52. We get down to 30 tonight. The hourly temperatures are above freezing. And then as you go into tomorrow, 52, looking at the sky, the cloud cover, we stay with low to middle level cloudiness, overcast throughout much of tomorrow. It begins to break up tomorrow evening. You look at the winds, they stay out of basically the southeast during this period, becoming more southerly as we move into Wednesday afternoon. But again, 34 tomorrow night, and then 58 by the time we get to Wednesday, late in the day on Wednesday. And then another mild night at 38 during this period. You can see the chances of precipitation increase into 67% chance in that 6-hour period ending at 6Z. So really mild weather forecast by the GFS model. And if we click this and go to /ADAMOS, we can also look at that. Again, this is for Madison, and we'll take a quick look at Astoria in just a moment.
Whoa, what a difference.
What a difference. And it might be how they're keeping the clouds in. Notice we say overcast throughout this entire period.
Right.
And these numbers are kind of consistent, even though we use the GFS to initialize the model. These are consistent with the MM5 temperatures that got us close to 50, but not into the 50s. So this is going to be a significant forecast challenge for these two models. And again, the showery or the chance of some precipitation, a little bit less of a chance in the in the NAM and the ADA model for the next that period. So that's kind of an interesting aspect.
The timing's the same, so everything looks the same time-wise, but 10 degrees colder is a substantial difference. Wow.
Right. Given the circumstances we're in, I just want to see us warm up. It'd be nice just to be in just more pleasant to be outside if anything.
Right.
If we go back to the aviation moss / new avian moss, let's do AST. This is Astoria. Okay. And you can see throughout this period, at least through tomorrow, kind of a wet period.
Yeah.
It kind of looks like in terms of temperatures, very much like Madison's temperatures in the NAM. But you can see temperatures approaching 50 degrees, 49, 39. And I guess that consistency from today and then the day after, pretty close, very similar temperatures, might be suggestive of the fact that you have this, at least at upper levels, wind off the water. But at the surface, it looks like these wind directions are pretty weak. I mean, the wind speeds are rather weak at only two knots. They kind of die off during the day tomorrow. So that's a curiosity. The probabilities of precipitation also begin to lessen a little bit over time. And if we look at the ADA moss for the same station, this is for the forecasting contest, those of you that are participating in that weather challenge.
Wow,
very similar numbers for this model as well. And the winds are just a little bit stronger here, and they have a bit more of a westerly component, particularly during the day tomorrow. So a lot of consistency in the temperatures. And then one last thing, Pete, if we could do /EXT. Yeah, John?
So looking at all those numbers from Astoria, I'd be prepared to forecast a high of 60 tomorrow and sunny skies and no precipitation, wouldn't you?
Yeah, if you want to really mess up some people's forecast. But no one else is listening, right, John? So we can say that.
No, that's true.
Yeah, /EXTAVN, please, Pete. I think this should do it. And then AST. We'll do AST. Got to make that a little bit bigger, if possible, or make these numbers smaller. Okay. So yeah, and it keeps, these are the temperatures. These are just the temperatures, raw temperatures right out of the model forecast. If we page through this, we can look at the precipitation amounts. And you can see the amounts for Astoria. If we want to, let's roll back up right there. That's great. We're from 6Z tonight, 0.09, 0.17, 0.21, 0.32. It's about 0.32 inches of liquid precipitation during our first 24-hour forecast period. And the period after that looks like it goes down a little bit. So precip is a pretty good bet. We could look at some things on the weather challenge page, but I think time is kind of running out a little bit on this. But you can sort of get a sense of the some of the data that we have available. If we go to the National Weather Service page and these are things that I had set up. We go to PDX or PQR space NOAA, do a search for that. That should take you to the Portland Weather Service office page.
Okay, 1 second here. Let me get back into the sharing.
EQR, that's funny. Why is that?
And they changed all those station names a while back.
Put an S in front of it. It's SPQR.
Okay, what am I searching for here, Michael?
PQR and then NOAA, and we should see the NOAA, see the Portland. Click on that, please. If you look carefully in the northwestern, the tip of the northwest, near the northwest tip of Oregon, you can see where Astoria is located. I don't know if we can zoom in on that, Pete.
Yeah, it's right at the mouth of the Columbia.
Yeah, a little bit to the north, right there. So that's where Astoria is located, and so that'll be something to key in on. I don't know, John, having gone to school in the Pacific Northwest, is there any advice you want to give forecasters, serious advice, that are going to be forecasting for that area?
This time of year, it's not really got a lot of local flavor, except for the cold air aloft behind front. So if you're looking at frontal analysis and you're not familiar with that phenomena of increased convective showers post-frontal showers, you can get really in trouble forecasting precipitation along the West Coast, especially the Northwest Coast. That's the thing in March that matters. Later in the year, there can be coastal marine air pushes that come up along the coast, and it can go from 83 degrees one day in Astoria to something like 63. And you think it's a drop, way down to well below Climo. It's actually a drop right to Climo in most instances. But the Portland to Astoria pressure gradient is a really important thing to look at for those marine pushes. But they're at another time of year. So there's nothing of particular local flavor at this time of year that matters too much.
Okay. And Pete, if you were to click on that Astoria as close to it as possible over land, hopefully it'll give us the Astoria forecast levels. We'll see the hourly weather forecast. Let's take a look at that. Actually, right now it's just partly cloudy there, but let's click on the hourly weather forecast. It's up a little bit with a cursor. It's at the bot that go down a little bit to the right. There we go, please. And so you can get a sense here from the, at least for the Weather Service, for the variation in temperature there, as well as the winds. The winds have much more of a westerly sort of flavor to them, and they're a bit higher than what the NAM and the AVN model had at about 9 knots or so, or 9 miles per hour, getting up to about 48, and lows in the middle to upper 30s, it appears. You watch out for the 6Z lows for them. But precipitation, and I guess it's midnight to midnight that we're interested in, but you can get a sense of that. It's about 0.3 or so by my quick calculation there. So maybe 0.3 to 0.4 inches liquid precip. And as we said, with this cold upper trough over them, possibility of some thunderstorms. You can see thunder is not out of the question for that station with the reds that you see there. So for this first forecast city, showery. I hate forecasting precipitation, but I guess that's what we have to do. Hopefully for this week, I won't forget to forecast like I did last week. I have to throw last station out, but it was in Alaska anyway, so no one really cares. But I think some folks did well at that station. So good luck everyone on your forecast for that. And maybe one last thing we'll do, Pete, if you have it, if it's available to you, going back, we can go to Pivotal and just take a look at the broader scale forecast. A couple things of interest I want to show at the very end of the period. This is with the GFS. We'll go to the surface data, please. And this is really kind of neat. If you go to 200 and that's the right map precip. And then let's go to 336. No, 240 hours first. Sorry, I think I got it wrong. 240, please. It's just a curious development, and this is actually not over us. You can see it looks pretty warm for us. If you look down to the southeastern Gulf of Mexico, you see this cyclone, which is actually an eastward moving. It's in a baroclinic zone, so this is a genuine just mid-latitude or very low latitude cyclone. If we just track it as it crosses the Florida Peninsula, if we go ahead to 276 hours, just to jump ahead a little bit so we don't take too much. 276, yeah, that'd be great. We're getting a really nice storm over us. But this thing crosses over the Florida Peninsula, moves into the Bahamas, deepens to 991. Kind of an interesting, it's a warm core disturbance at this point. Let's watch this as it moves northward and the interaction it has with the cyclone that's over Minnesota. So we'll go to 300 hours.
Really interesting.
Yeah. So we can see with this deepening cyclone, cold advection in the lower troposphere, presumably diminishing with height. We have this subtropical or extratropical cyclone that's off the southeast coast, the drifting northward. In the models, they have an interaction with us. Let's go to 324 hours, so 24 hours after this map time, please.
Snow showers on Sunday, April 5th.
And it looks like, oh, this thing's about to go out to sea. If we scroll over a little bit, we can sort of see the interaction of these two. This cyclone's gone way out to sea. You say, oh, it's pretty much game over. But you notice this upper trough that extends all the way back into Quebec. Our surface trough that goes into Quebec, and you can get a hint from the thermal structure of there's an upper trough over Pennsylvania and New York State. So if we go ahead, this is what, 324 to 348. Actually, just go 12 hours ahead, in fact, just 336. Let's do that.
It's like the perfect storm.
Exactly. It looks very much like the interaction of Grace with an upper trough. You'll see that this comes into a pretty significant snowstorm right off the East Coast. It's this, part of the disturbance that had origins at very low latitudes drifted northward. It's not the same cyclone by any stretch. no pun intended, vortex stretching, but it is perhaps influenced by that particular cyclone, and that gives eastern New England and southeast, just eastern and northern New England a significant snowstorm if this were to verify.
Wow.
We can go ahead another 12 hours just to see the wrap up of this at 348 hours. That's down to 976 from just an inverted trough. They extend it to the northwest of the cyclone to something that's that intense.
That'd be almost their first snowstorm of the year in New England, southern New England.
And so there it is going out to sea after that.
Wow,
but,
that's impressive.
So something to watch. Hopefully get something exciting like that occurs. When I first saw that thing in the southeast Gulf of Mexico, I was like, could that be an early season TC? But of course not. It's way too soon. And it's baroclinic. So just an interesting pattern setting up. But the big story is a warming trend for us over the next few days, but also looking ahead into next week. We haven't really focused on that warming up, and we'll talk about that, I guess, on Friday. We'll have much warmer weather coming up, maybe into the 60s perhaps shortly.
Very nice.
All right. Well, anyway, thank you, Pete, for setting this up, and John for
thanks,
great weather discussion on that. That was really great, and Greg as well for sharing
same to
some of
both
the
of you
jet
guys.
structures.
I will use the same link for future versions of Weather Watch. So if you want to bookmark that, you can. I'll just change the start time to be 12:15 on Friday.
Okay.
I think this went pretty well. I think for Friday, I'll go ahead and send the link out to our Facebook and Twitter friends so that additional people can get on. I think this went pretty well.
Okay. I'll try to figure out what happens with my sharing application screen. Sometimes I can't see what the button after I share application. I can't see the options pop up.
Interesting. Might be
I had something weird like that yesterday.
Yeah, closed Chrome and restart, or hopefully not a full machine reboot or anything. But
yeah, this is Firefox, but yeah, maybe the same issue.
We can
one
that
other thing,
up.
I guess the people are still on. If you were to use the same link and you're doing a recording this, how is that going to work? Is it going to just lengthen the recording?
It'll be a completely different recording. I'm going to go ahead and stop the recording now since we're pretty much done, but we can stay on here and continue to talk logistics.